Assalamualaikum. I Syabir Izzat will explain about the introduction of the project. Basically, the project is about castle drawbridge mechanism. So I will explain the background of the project and the mechanism of a drawbridge. The project background. Uh, as we know, drawbridge have evolved over many centuries. Its purpose changing over century. In the medieval time, the drawbridge main purpose was defense. Medieval drawbridge use a one-leaf system, which means that the one side of the drawbridge is a pull-up, while the modern is a two-leaf system, which open the drawbridge in the center. Most modern drawbridge work through counterbalance, though the mechanism is condensed to take up as little space as possible. Underneath the drawbridge, there are counterbalance of very heavy material, usually concrete, which is lower to move the bridge up. Crank rocker mechanism. Crank rocker mechanism is a four-bar linkage. In this linkage, the shortest link rotates fully while the other link pivot to the fixed link oscillate. The diagram shows the Grashof linkage, for which the sum of the length of the shortest link and the largest link is less than the sum of the length of the other two links, which is S plus L less than PQ based on the diagram, which S is equal to length of the shortest link, L is equal to length of the largest link, P and Q is the length of the other two links.
Okay, so I'll be talking about the available design in the market right now. We have three designs, which is the Kuala Terengganu Drawbridge in Kuala Terengganu, Tower Bridge in London, and Chicago's State Street Bridge. So for the first design, the Kuala Terengganu Drawbridge, the design was actually inspired by London Tower Bridge in London. The drawbridge has a 23-meter wide single carriageway that spans 638 meters over the mouth of Terengganu River. Meanwhile, Tower Bridge of London, the bridge is 240 meters in length and consists of two 65-meter bridge towers connected at the upper level by two horizontal walkways, and a pair of bascules that can open to allow shipping. Originally hydraulically powered, the operating mechanism was converted to an electrical hydraulic system in 1972. And meanwhile, Chicago's State Bridge is a movable bridge which was pioneered in Chicago. The vertical lift was designed by J.A.L. Waddell, and the vertical lift actually relies on counterweights. The entire bridge roadway is elevated by counterweights and machinery in two towers. So for the selection design, our design is inspired by the three available designs in the market right now. We designed a drawbridge ourselves that has a simple motion but completes the task assigned to it. And this includes a crank rocker mechanism that allows a motor to pull up the bridge and lower it back down when needed. And the simple design allows for fast but reliable construction, which in turn results in cost-effective bridges.
In designing our bridge, there are a few considerations that we have to keep in mind. Number one, the point of interest has to rotate about 90 degree. Number two, degree of freedom is equal to 1 since it's a crank rocker mechanism. Number three, the velocity and acceleration must be relatively safe. Number four, it has to accommodate the required load. Number five, S plus L must be lesser than P plus Q. A diagram below shows the position analysis at a point of interest. One thing to note here is notice how the arc of the circle form a 90 degree and both of the circle does not collide. Diagram below shows the velocity analysis. From calculation, we found out that the velocity at the point of interest is 3.42 meter per second, which is relatively safe for a drawbridge. In this diagram, we have identified the acceleration as a product of tangential and normal acceleration to be 1.836 meter per second square when input of 2 RPM is applied from the motor.
Okay, my name is Ahmad Abqari bin Muaz, and now I'll be concluding our presentation. So the first point is the velocity at the point of interest to be 3.42 meter per second when input of 2 rotation per minute is applied from the motor. The second is the acceleration as a product of tangential and normal acceleration to be 1.836 meter per second squared when input of the same 2 rotation per minute is applied from the motor. And finally, the objective for this project were met as stated in earlier slides. So we have made our objectives for this project. And then finally, we have the recommendation for this project. So for future work, this project always have room for improvement. And as in this project, we use the double leaf drawbridges for the design, and double leaf drawbridges should be supported on a very live load shoes located adjacent to the PLC wall. So in this diagram, we can see that the live load shoes located at the bottom of the bridges, and it will help the bridges to rotate further so it doesn't damage the bridges. Thank you.